Okay. I'm going to remove the flywheel now, and I want to show you right here is the key notch. There's the notch in the flywheel for the key that's in the crankshaft. This shaft that comes through the top of the motor is actually the output crankshaft on one side, and the output crankshaft on the other side is below the mower deck that attaches to the grass cutting blade clutch assembly. This key exactly represents top dead center piston movement. So on one rotation it is on its compression stroke, and that obviously was the compression stroke. And at this rotation, this is at the top of the exhaust stroke and the beginning of the intake stroke. Notice that for every rotation of the flywheel, this magnet assembly moves past the magneto coil pickup assembly. And when it gets right here, it initiates a spark to the spark plug. So this engine generates 2 sparks for every power stroke, for every 1 power stroke. This is important because on a power stroke, or on the compression stroke, when you want the spark, both valves are closed. The chamber is sealed, it has compressed gas and fuel in it, and it ignites and it provides power to keep the engine rotating in one direction. On the exhaust stroke, when it comes around to top dead center, well, I should say right now this is probably 20 degrees before top dead center, which is where it's timed for gasoline. Hopefully at this point the intake valve is still closed and the exhaust valve is completely open when it generates what we call a waste spark. And the waste spark is only there to help reduce emissions of the engine. It doesn't help with the combustion process. It doesn't help increase the efficiency of the engine. It only helps reduce the emissions. That's all well and good, except I want to move the spark to a point where the engine is at or beyond top dead center, in which case the intake valve is already open. And if I have HHO present going into the cylinder and the intake valve is open and a spark goes off, guess what's going to happen? It's going to backfire, and it will backfire all the way back to the bubbler every single time. The object now is to find where the valves are controlled, and I think it might be behind this plate, where I can get a rotation of the crankshaft, or I'm sorry, not a rotation of the crankshaft, but the rotation of the camshaft that drives the valves, because it's the position of the camshaft that's important. I want it to skip every other spark when this flywheel goes around. I don't want it sparking at the top of the exhaust stroke and the beginning of the intake stroke. So that's one of the challenges to getting an engine such as this to run on pure HHO. Not only do you have to advance the timing, but you also have to control when the spark fires. It may even require a secondary ignition system, something completely separate. But what I'm going to do is I'm going to place a mark along the engine housing and a mark on the flywheel, and I'm going to use a timing light on the spark plug itself, and I'm going to see where it is in terms of degrees. Alright, and I'm actually going to measure how many degrees before top dead center this engine is firing right now before I start making any adjustments. So right now I'm going to remove the flywheel, and what I'm going to do is I'm going to place the nut that holds the flywheel in place on the threads, but not all the way down, because I don't want to peen the end of the shaft. I'm going to tap this with a small sledgehammer as I apply pressure upward on the flywheel, and that vibration is going to shake the flywheel loose. Well, unfortunately it doesn't show up very well. Maybe if I put this behind it you can see it a little better. But you can see that the output shaft is tapered. It's much narrower at the top than it is at the bottom. And here's the key that locates the flywheel to the output shaft. Okay, the key is just a little half-moon shaped piece of metal that is notched into the tapered surface of the output of the crankshaft of the engine. So what I'm going to do for my test experiments is I'm simply going to mark where this lines up to the crankshaft, but then I'm going to eliminate the key, and I'm just going to tighten it down with the nut. And the fact that we have a tapered shaft here is enough to lock the flywheel into position and prevent it from shifting around on the crankshaft, so that I can run some experiments with adjusting the timing, and eventually I may rekey the shaft and rekey the flywheel so that I can find that position again right away. And that's the only benefit. It allows you to find the exact same position every time when you stick the flywheel back onto the crankshaft output. Alright, I'm going to go ahead and put the flywheel back on, and then I'm going to assemble the pull start mechanism to the top of these posts, and I'm going to leave the fins exposed. If I was driving this motor under full load for an extended period of time, that might cause damage to the engine, but because I'm only idling it and because I'm only running it for short duration tests, it should be fine to just leave the fins exposed like a motorcycle engine and not have to worry about this engine overheating for the short duration tests that I'll be conducting. By the way, I don't know how often my head has appeared on camera here, but obviously you can tell that my hairline is receding. In a couple of previous videos, my belly showed up on video, and some of the ads that appeared on my channel, on my watch pages, related to weight loss and lose your stomach. So obviously somebody at YouTube has a good sense of humor. Hopefully I don't start seeing ads for hair loss restoration. That would be just a little tacky, okay guys? Please don't do that. I'm self-conscious about it enough. Okay, so obviously, as you can see, finding the right number of shims and spacers to replicate the thickness of the plastic created by the top hood was a little tricky, but now that I've got the correct spacing on here, I can put the recoil assembly back on top of the posts and crank the engine over like that. Alright, so there we have it. An engine without a carburetor. Next phase obviously has to be now to locate the camshaft output so that I can attach some sort of pickup assembly that's going to allow me to electronically, every other rotation of the flywheel, cancel out the spark so that I don't end up with a waste spark at the top of the exhaust and the beginning of the intake stroke. I'll be using a basketball filler needle to inject the HHO directly into the top of the engine, right above the intake valves. And that's it for phase 1. Zero fossil fuel. Signing out for now. Everyone have fun, and please be safe.